Welcome to the Stutzman channel. As you all know, it is summertime right now and it is hot, and I'm sure that you have your AC running or heat pump. It's the same difference. And in this video, I'm going to show two different methods of how you can check your capacitors that's in the outside unit for the compressor and also for the condenser fan. Now, traditionally, one of the methods is that you power the unit down, and then you will take the wires off of the capacitors, and then you will take a capacitance meter, and then you will check how many farads you have. The other method is where the unit is running, and while the unit is running, we're going to get a couple of measurements, and then from that we'll make a calculation, and we'll see how our readings will compare. The second method is a little bit more accurate, or should be, because we're looking at it under actual dynamic conditions. We have the heat involved, we have the current there, we have the high voltage across the capacitors, so we'll see what we got. Now, the first thing I'm going to show you is the method where we power the unit down. Now, what I like to do is I turn off the thermostat. Now, I've already turned it off. It was in the cool here, and so I have it in off. Now, what this will do is it'll turn off the contactor. It's not a necessary thing because we have a disconnect outside, which we're going to do that too. So now let's go on out, let's go to the outside unit, and let's take a look at this here capacitor. Now, as you can see, the unit is off, but treat it like it is hot, because you may have a problem with one of the windings may be open, maybe the capacitor could be an issue, maybe your disconnect could have an issue. So even though it's off, treat it like it's hot. Now, the next step we want to do is we want to turn off the disconnect. Now, I have two units out here, two heat pumps, so you can see that this here circuit breaker is going to the left. This is the one we're going to be looking at. So I'm going to turn that one off. We're going to remove this here access cover to get inside to the electrical components. Now, your situation may vary. You may have more screws. On mine, I only have two, so I have one over here and I've got one over here. So when I get these two screws out, I'll catch you guys in the next shot. Now, even though the unit's not running, as I mentioned earlier, treat it as it's hot until we get a voltmeter in there and we actually check to make sure that that voltage is off on both legs. This is a 240 volt split phase system. Now, I'm going to be, for a little bit of safety, I'm going to be using a little bit of PPE, personal protective equipment. That includes the safety glasses, leather gloves, and some rubber gloves that's rated up to 500 volts. Now, I'm not dressed with arc flash rated clothing, but I'm going to be very cautious, very careful, and so that's why I'm stressing that if you're going to be working on stuff that's hot, which we will be later, be very careful working with these high voltages. So I'm going to go ahead and I'm going to put the PPE on. And then we're going to go ahead and we're going to make some checks on the voltage to be sure that this thing is off. Now, if you feel like that you're uncomfortable working with high voltages, or that it could be voltages there, even if you turned it off, then I would recommend that you actually get somebody else out here to, to check your unit for you. The gloves here, they're rated for 500 volts. And the leather gloves here are actually for protecting the rubber gloves. So that way you don't get nicks and cracks, or punctures into the rubber gloves. And also safety glasses. The first thing I'm going to do is I'm going to check on these here two lugs on this here contactor. This is where the line power is coming in. So between here and here, if this was on, I would have 240 volts. So as you see, I got 0.04 volts. Now I'm going to check from one side of the line, and then I'm going to go check to the ground, equipment ground. Equipment ground, but goes all the way back to the service panel where it bonds with the neutral. So as you see, I have 0 volts there. And then I'm going to move my lead over to the other lug, and I have 0 volts there. Now, between each lug and ground, there should be 120 volts. But as you can see, we have nothing. Now, this is our capacitor. It's a dual capacitor, Now some of them will be round, as it is in this case, a cylindrical shape, and then some of them might be an ellipse. But this is what it's going to be. Now we're going to have one capacitor, and I wrote it here. It's a fan. So this here is going to the start winding. Sometimes that's also called an auxiliary winding because the capacitor stays in place even after it's started. Also, this on the back here with the yellow wire is going to be my Herm. This is for hermetic compressor. This is also going down to the start or auxiliary winding for the compressor. Now this here final terminal over here, we got a red wire and we have a purple wire. This is a common terminal. This common terminal means it's common to these two capacitors. Okay. Now when we're going to pull the wires off of here, so you don't get confused of which one of these wires goes where, you just draw a little diagram so you'll know that where to put these wires back. I have here a little device I made. It's nothing no more than a 20,000 ohm 5-watt resistor. So I took this here test light, old test light, and I took the guts out of it, took the spring out, took the bulbs out, and I took that resistor and I soldered it into here and to the lead. I changed out the clip so it'll be a little bit smaller, and also I put a little bit of heat shrink over this here probe so you wouldn't have a chance of shorting something out. So I'm going to take this lead, I'm going to hook it up onto the common terminal. So we got it on the common terminal, and now what we're going to do is we're going to discharge this capacitor if there's any voltage that's on either one of these two capacitors. Now more than likely there's not going to be anything on here because we have our start winding, so when the unit is powered off then the capacitor can discharge through the start windings. However, if you have a open winding, say for the start winding, then this capacitor can still be charged up. So always assume that everything is got voltage on here until like we get this thing discharged. So now I'm going to put it on, say, the fan. So I put it on there and I'm going to count 1001, 1002, 1003, 1004, 1005. Now that capacitor should be discharged. Now I'm going to go back here to the one for the compressor. I'm going to hit it, 1001, 1002, 1003, 1004, 1005. And now that one should be discharged. So now we should be safe to pull the wires off and not have to worry about getting a shock. Now we'll talk about that this here resistor and the bleeding off, and probably why it's a good idea to use a device like this instead of taking a screwdriver and jumping across terminals. So you see a lot of people do that, but we'll explain that in the next video. Well, we'll cover that a little bit more in detail. We'll talk about time constants and discharge current and why this is bad. So anyway, now we're going to take and we're going to remove these wires here. Now when you remove the wires, you want to be checking to make sure that this here fast on terminal is secure to the terminal. So you don't want it to be loose. So you can tell that when you're pulling it off. Turn the capacitor just a little bit so I could see the readings over here on the side. Right here is our common terminal. This over here is our fan terminal. So this is what we're going to check first. So we'll look up there at the meter. What do we got?
4.93.
All right, 4.93 microfarads, okay?
Yeah.
Now, where I was on the fan, I'm going to move it back over to the Herm terminal. So now between the common and the Herm. What do we got?
38.16.
38.16?
Yeah, 38.16.
Okay. Now, nominally, these here two capacitors, they should be reading 40 microfarads and also 5 microfarads. So the one for the 40 microfarads might be a little bit low. This here capacitors, they should have a plus or minus 6% tolerance. So let's see, 40, if we take 6% of that, that's 2.4. We take 2.4, we subtract from 40, we get 37.6. So we're still within spec, but only by one microfarad. So at this point, then I could be looking at, well, it might be a good idea for me to go ahead and change this here capacitor because this here value is getting a little bit low on the, one for the compressor. Now, as far as the other one, for 5 microfarad, then that was 4.93 plus minus 6%. So we're within spec on that. Okay, I've already turned the circuit breaker back on. I went back inside. I turned on the thermostat to cool. You can see the unit is running now. And now what we're going to do is we're going to get an amp clamp set for AC amps. Now, we're going to check both capacitors here. So we're looking at the one for the compressor and also the one for the condenser fan. Now, the yellow wire is going down to the compressor. So that's for the start winding. So what we're going to do is we're going to get an amp reading on that. And I got looks like 4.78. Okay? So I'm going to record that measurement. Alright, now the one for the fan is this one right here for the brown wire. So we're going to get an amp reading on that one. And I got 0.62 amps. So we're going to record that one.
342.8. 342.7.
Alright, 342.7.
Yeah.
Alright, this is the one that's across the compressor capacitor. 342.7.
7. $342.7. Now.
Alright, now we're looking at the other one. Okay, you still filming?
Yeah.
Alright, now this one is going to be for the voltage across the condenser fan capacitor. That's from the C terminal to the fan terminal. What do we got?
343.3.
343.
Jumping a little bit. 342.5. Kind of jumping.
Alright, we'll call it 340. We'll call it 342, I guess.
Yeah.
I think you can agree by getting the amperage and getting the voltage that's on those two capacitors is a lot faster than what we did earlier in shutting the unit down, making sure the power is off, then we got to discharge the capacitor, then we got to pull the wires off. Where if the unit's running, we just go in there, get our voltage readings and amps, and we're done. So let's go inside and let's look at the calculations and let's see how we pair it up on this capacitors and see how well it checks with the meter that we did initially. All right, now to start off with, let's write down here, this is the measurements we made with the power off. So we were using a capacitance meter. So for the compressor cap, we had 38.16 microfarads, and for the condenser fan cap, we had 4.93 microfarads. Now we came back and we took the measurements while it was running. We measured the amps for the compressor cap. That's going to that's for the Herm wire, and we got 4.78. The volts on that capacitor was 342.7, and on the fan capacitor, we checked the amperage on that, and we had 0.62 amps and 342 volts. So amps, volts. Now what we're going to do is we're going to write down this number, 2652.58. So this is our magic number. So we're going to take this number and we're going to multiply it times our amps. So we're going to say times 4.78. So let's put that in the calculator. So I have 2652.58 times. Our amps is 4.78. That's going to be equal to this. Now we are going to divide this number that we get over here, and we're going to divide it by our voltage of 342.7. So we're going to divide it, we get 342.7, and we get 36.998. So we just rounded off, say 37 microfarads, okay? So this one over here, 37 microfarads. Now you see we measured with a capacitance meter 38.16 microfarads. So we're 1 microfarad off, well within tolerance. Now let's take a look over here at our fan capacitor. We're still going to use the same number. We're going to use 2652.58. We're going to multiply it times our amperage, 0.62. We do that and let's see what we get. 2652.58 times 0.62. That's going to be equal. And let's just go ahead, we'll write it out. 1644.5996. Now we're going to divide that number by our volts, which is 342. So I'm going to divide that by 342 equals. And you see we get 4.81. I'm going to round it off to 4.81. 4.81 microfarads. And if we look down here, you can see that we had 4.93 microfarads. So we're only 1/10 of a microfarad off. So there is a way to measure capacitance while your unit is running. Save you a little bit of time. You can go out there and you kind of spot check maybe once a year about your capacitors to see if they're still in spec. Now I'm still in spec, but I was getting a little bit low on my 40 microfarads, so I think what I'm going to do is I'm going to go ahead and I'm going to order a capacitor to bring that capacitance up on that one for the compressor. So you may be wondering where did this number come from? 2652.58. How do we know to multiply it by amps? And how do we know to divide by the voltage? Well, you're just going to have to wait for the next video on that. Because I know there's a lot of guys out there, okay, give me the information, here you go. You got the information, and you don't care how it works, and that's fine. Because some people like to take an aspirin because they know it's going to get rid of the headache.
Exactly.
But then some people take the aspirin and they want to know how it works. So the next video is going to explain how all of this works, where these numbers come from, and why we multiply by amps and divide by the volts. And I'll explain all that in the next video. So you guys take care, and we'll see you in the next one.